P.S. This weekend, if you get totally stressed out, not that I should need to tell you this, but it's okay. If you get totally stressed out, what should you do? Sit there and stew and just make your brain focus for another 4 hours when you're totally stressed out? Whenever you're doing final prep, especially for a class like calculus, if you're getting in a funk, if your brain is just being blocked, I need you to separate yourself from the studying at least for a little bit. Maybe call a friend who will encourage you, have a little lifeline. Maybe just listen to music, maybe just go look at Christmas lights, maybe go grab a Starbucks, I don't know. Something to distract yourself, something to just kind of reset your buttons. Yes, you can cry for a little bit, that's not totally bad. But you can't sit and be stagnant and be like, I studied 10 hours. But you were totally stressed out the entire time and barely focusing. Does that make sense? Remove yourself from the situation every now and then this weekend. Okay? If worse comes to worse, if you need a break, just peek at your forever cards. Yeah? That's a good thing. Multiple choice can be overwhelming sometimes. Or go review a topic or listen to me reteach a topic or do an example on related rates or optimization. There are ways to separate your brain from whatever's overwhelming it at the moment. Okay? Okay. Here we go. Number 4. Right away as I'm looking at this, I do see a few different things. It does look a lot like a difference quotient, and so some of you guys might be like, hey, derivative, how can I make that work? We could try to make that work. It's going to be a little bit messy, but not going to be totally impossible. So I'm going to do this 2 different ways. One way is using the definite form, and the other way is good old-fashioned. Let me do the good old-fashioned first. Good old-fashioned, this is the limit. Good old-fashioned, I have a function I can plug in. Good old-fashioned, I say, who is f of x? 2x squared plus 1. I'm putting it in the f of x spot. Minus f of 0, 2 times 0 squared plus 1, all over x squared. If you were to plug in 0 right now, guess what? 0 over 0. Old-fashioned, keep going. How? I don't know. Get all that together somehow. So therefore, we have 2x squared plus 1 minus ultimately 1. What can we do? Reduce the x squareds, and we end up with a final answer of 2. However, if this was a different function other than 2x squared plus 1, if it was an e to the, or an ln, or a, you might not know how to do the old-fashioned way. So let's quickly look at how this is really just an alternate form of the derivative. I'm going to the forever card right now. F prime of a can equal a couple different forms. One of them is the limit as x goes to a of f of x minus f of a all over x minus a. Do you guys see how I have an a? Do you see how I have an a? Do you see how I have an f of x? Now, it might be a little weird to see exactly how this works. Let me go ahead and plug in, if I was to plug in, to show you how these are the same. The limit as x goes to a of f of x, 2x squared plus 1, minus f of 0, which would be, what do we have? 2 plus 1. There's my f of 0. All over x minus 0. Ooh. Ooh. Wait, does my definition, my limit definition, does it account for this guy ever being a squared? The answer is no. So actually, even though sometimes things look like definitions of derivative, just because there's some sort of weird notation doesn't always mean it must point back to the definition of derivative. This one actually was only solvable the old-fashioned way. So don't totally disregard the old-fashioned way. Don't totally disregard the old-fashioned way, or totally ignore all problems back in Chapter 1 and Chapter 2, specifically 2.1, the definition of derivative, where we actually had to do this the long way, because this question was actually not a derivative. This square does not match my definition. So be careful. They might force your hand to do some of the math with the definition of derivative. Force your hand to do some weird plugging in and simplifying. Anyway, number 4, Patricia, good question. It was not a derivative after all, even though it looks so similar. It was just an old-fashioned plug in, simplify, solve. I don't know what page this was from. Sure sounds like MBT, though. Was this one yours, Nick? The derivative applications? Okay. So with this one, the MVT application, derivative application page, which of the following functions shows that, oh, this is a great AP question. Continuous means improper, but continuous means the function works at 0. What's differentiable mean? The derivative works at 0. Do you guys see the difference? Differentiable has to do with being able to derive. Continuous has to do with the original function working, having to do with the limit being the point, etc. So which of these? Here's what I see when I look at this. I see negative exponents, and I remember real quick, just off to the side, remembering old school math. Whenever I have an x to a negative exponent, doesn't it mean 1 over? Just real quick, like pre-cal stuff, right? So why am I going to automatically cross out this one and this one, saying this has nothing to do with this problem? What's wrong with these two? They're negative exponents, which means the x is in the denominator, which means the function is not continuous at 0. If you have a denominator, plug in 0. That doesn't work. That's going to be undefined. Okay, so let's look at all of these ones. Nick, go ahead. You want to find one that's false. Here's the struggle. In order to make this statement false, it goes back to logic and geometry and if-then statements. To make this false, you need to have this condition be true with a different outcome. Does that make sense? Yeah. So we're looking for where this is true but a different outcome. That makes it. Okay. Because if this is false, then we have no idea what is happening. Okay. So all of these are continuous because all of these are positive exponents. I can plug in 0 just fine. They actually all equal 0 when you plug in. I'm looking for derivative wouldn't work. 3x squared, plug in 0, he's fine. 4/3 x to the 1/3 is a positive exponent. He's fine. What's wrong with letter C? His f prime would get us what kind of exponent? His original function works, his derivative doesn't work at 0. Does that make sense, kind of? Final answer, letter C. Next one. Uh-oh, maybe on the same page? I feel like this was on a different page, though. Same page? Different page. Do you know which one, AJ? Oh, the other derivative applications page. Okay. The mean value theorem guarantees the existence of a special point on the graph between, oh yeah, this is a nice one because I don't tell you how to do mean value theorem. But cool kids, there's a formula for that, right? Does an MBT say? We don't even have to do the if. They told us MBT applies, so we're going for it. So f prime of C is equal to f of B minus f of A. Got it. Remember f of B minus f of A, isn't that just y2 minus y1 over x2 minus x1? But pause, 1/2 is not your answer. But see how they have a multiple choice answer with 1/2? Just waiting for you to circle it. But it's wrong. Because what's on the other side waiting for you to deal with it? The derivative. So who is the derivative? F is equal to square root of x, which is continuous and is differentiable if we were to go through and show that, between 0 and 4. But you also need f prime of x. Remember, bring down the 1/2, negative 1/2. So we need to set this equal to 1 over square root. And I just do x. I know the theorem says c, but remember, c is the special x in the interval. So you could just take the derivative. For Rolls and MBT, Rolls is just special because this becomes a 0. Derivative equal to 0 when f of A equals f of B. MBT, you have to actually plug in the formula. It's a number. Set the derivative equal to the number. For both theorems, you're finding x when setting the derivative equal to the average rate. Now it's just to solve. So I have 2 root x, is equal to 2. I just cross multiplied. Root x is equal to 1. Pause. The answer would be none of these if 1 does not work in the interval. But does it work? Yeah, 1 is in between 0 and 4, so therefore I can say C is 1. Wait a minute. Why are there two things? Coordinates. An x and a. So careful. Couldn't they theoretically have a none of these? Because maybe this isn't the correct plug-in, but plug in. If x is equal to 1, what would y equal? 1 also. So yeah, B is your final answer. Inflection point. That's going to be a different page. Concavity, is it that one? I think it's the concavity page. Inflection point. What does it take to have an actual inflection point? Find the pips and then test. Find the pips and then test. Pips say look to what derivative? Second. Man, this looks an awful lot like a test problem. Maybe this is where I got it from. First derivative, dy dx. But would you get it right this time? That's the question. Would you do second d first? Arctan of x times 1 plus first d second. Isn't the derivative of arctan? Oh, come on. You did corrections. What's the derivative of tangent inverse? 1 plus u squared times u prime, right? Are we okay? 1 over 1 plus x squared? Second derivative. Derivative of tangent inverse, 1 over 1 plus x squared. Now you guys remember it. Ooh, isn't this got a quotient rule? With a top and a bottom. So we have bottom, d top, plus, no, quotient rule is a minus, right? Minus top, d bottom, all over bottom squared. I am not going to do the green trick because it doesn't work on this one. I'm going to multiply top and bottom by this guy because I want a common denominator because pitchforks are so much easier when you just have one fraction. So this guy is going to end up being 1 plus x squared. And he's going to be able to join because now they have common denominators. Over here I'm going to have 1 plus x squared minus 2x squared minus x. Ooh, 1x squared, 2x squared, negative 2x squared. And then I have my 1 plus x squared squared, which will be 2 minus 2x all over 1 plus x squared squared. Pitchfork. X equals 1 is 1 pip. Second derivative equal to 0 or dne. Why am I going to say none on the denominator right away? I'm doing math in my head, setting equal to 0 like I should, and what am I seeing? But why can't it equal 0? Set equal to 0, no big deal. X can equal 0, that's fine. Imaginary. If you set equal to 0, square root both sides. You always set equal to 0 and try, but I'm just saying none because I already in my head saw I subtract a 1 and square root a negative. So I'm saying none because I already did the math. Wait a minute, so x equals 1, done. Well, if you're speeding along and see that there's none of these options, then yeah, pick one of the ones. But technically, if it's a nasty problem, what could they do? Have a none of these and have a problem where the second derivative doesn't change signs. To have an inflection point, a pip is not enough. Technically, there needs to be a sign change. So you could plug in like 0 and see that's a positive, and then plug in like 3 and see that that's a negative. Truly, there is a sign change, so it is legal to say point of inflection, but how do we know whether it's D or E? Unit circle, because you have to be able to plug in. So plugging in 1, you do end up with f of 1 or y at 1 is 1 plus 1, 2 times arctan of 1. I know not all of you use the cheater chart, but I love it because you can sing the bottom row of it. Square root of 3 over 3, 1 square root of 3. Not pi over 6, not pi over 3. It's in the middle, pi over 4. So it's going to equal 2 times pi over 4, which is pi over 2. Logarithmic page. These are the ones that Eurus was asking on, number 4 and number 5. Logarithmic page. Logarithmic page. Why am I also saying implicit differentiation? Why am I saying logs and implicit for this guy? The y's. And every time you take the derivative of a y, what do you get out? dy dx. Good. So when I go to do, I'm just going to split the page. When I go to do number 4, I have to use the derivative rule for implicit, where I take the derivative basically of both sides, even though the left side is pretty basic. So the derivative of y is 1 dy dx. Sometimes that's more complicated, but that's all for right now. But what's the derivative of ln? Yeah, 1 over the u, right? Times, which is 2x plus 2y, don't kill a bunny, y prime. I'm not making a table, sorry, I'm just splitting up so I have room for both. I'm just waiting. Don't we need to get dy dx by itself? Wait! Pause. Maggie Corey's favorite. Arian disagrees, but Maggie gets it right a higher percentage of the time. She says, don't simplify, plug in right away. Why? If you start simplifying, what could you do? And we're plugging in anyway. So why don't we just plug in x and plug in y and then figure it out? It's up to you. Maybe you want to make it look pretty and then go, or maybe you just want to plug in. It's up to you whether to go with Maggie or Arian on this one. But Arian's maybe going to be convinced. We'll see. dy dx is equal to 1 over, what's 0 squared plus 1 squared? Oh. Times, what's 2 times 1? 2. Plus, what's 2 times 0? It didn't even matter. No, that's usually not the case. But it didn't even matter. We didn't even have to get that dy dx over here, because at this one point, it goes away anyway. Well, that's kind of convenient, because what's my dy dx? If you had simplified correctly and gotten the dy dx's on one side, you would have gotten the exact same answer. And if it had been a number with dy dx, we would have distributed and then combined like terms, and it would have been theoretically easier. Number 5 says, stink. Hold on, I can't see what it is. Oh, e to the nx? Okay. The derivative of e to the u is e to the u times u prime, right? And isn't n a constant? Huh. So my first derivative, which is dy dx, is going to equal n times e to the nx. My second derivative, why am I taking more than one derivative? You see how that's the nth derivative? We're trying to find a pattern. This is going to be n times n e to the nx. What's my third derivative going to be? N times n times n times e to the nx. Am I going to have as many n's as this? Oh, so isn't it going to be n to the n, e to the nx? Dun, 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 dun. I didn't even answer this one. Lo siento. Dun, 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 dun. Hold on. N to the n. N to the n. Yeah. E to the nx. Booyah. Huh. We made it all the way to the end? Pause. Did I make some of those look real easy? Why? I look at a problem, I attach it to a concept. Just don't even think about how I've been doing this longer than you. I look at a problem, I analyze what it needs, and then I go through the steps to get there. If I get stuck, try it for a little bit, I move on, let my brain recoup, then come back. Because even when you're proofreading like an English essay, don't you sometimes miss mistakes the first 5 times? You got to give yourself space and then try? Or have someone else proofread. That's not the final. Sorry, lo siento. You, yourself, and you. Study this weekend. Forevers. Study problems. I'll be here after school if you need me. But please, if you are worried about this final, group up with someone, because sometimes an extra pair of eyes is all you need. Grab me or give me. Your test folder's on the way out. You guys got this. P.S. Monday, come early. I'll probably have breakfast for you. Grab coffee, grab breakfast. I mean breakfast, not just donut holes. And then you won't be stressed, and we'll be able to calmly start our final. I don't want your phones.